Okay, so now we will discuss the vapor pressure and the cavitation. Just quickly, we'll try to understand the definition of the vapor pressure and the cavitation. So this is one of the most important concepts that we need to understand clearly. So you can see here the vapor pressure, we say the pressure exerted by the vapor over a fluid. You can see a bit detailed definition here, but what I will write is I can say the vapor pressure, just I'm just using this abbreviation. The vapor pressure is the pressure exerted by the vapor over a liquid or fluid. So that's what I'm telling. So in simply you can say the vapor pressure, this is actually the pressure exerted by the vapor over the liquid. So for better understanding, look here, we have got just a container. Let's say this is a container, it is filled with water. Just let's say the 2/3 is filled with water and the half it is just empty. Let's say this is just empty. We put a cap over there, so that means in general if you filled a container with water, you can see after 2-3 days there is no more water, because water generally, it just what happened, it vaporized and it just go off. So if we just put the cap here, and then if we put a let's say a candle, some flame, that means we're just heating the water, and the consequences. So if you heat the water at 100 degrees centigrade temperature, the water is dead, vaporized, like the phase changes state over there. That means the water molecule, it will become vapor, vaporization will happen, and due to the light, vapor molecules, it's light, then the water molecules, they will go up, but this is closed. This container, we put the cap, it's closed, so the vapor it can't go out of the container. So what happen is it just does this the top of this container, so it puts some pressure over there, so the vapor applies some pressure over there. Okay, so in such way, it is a continuous process. It happens again and again. So some molecules just come down this way, and they also apply some pressure on this interface, this vapor water interface. So the pressure exerted by the vapor over the liquid, this is actually called the vapor pressure. So now what I said is, when we are applying the temperature, when we're increasing the temperature, the vaporization will increase, and it will exert more pressure. That means if we increase the temperature, so if you increase the temperature, so that means the vapor pressure, it will increase. So that's the thing, the vapor pressure will increase. So now in a state of this flame, if you put some sort of ice, so that means you're trying to reduce the temperature of this, which will generate less vapor, so that will produce less pressure. So that means if you decrease the temperature, okay, then the vapor pressure, it will also decrease. So now the cavitation. So I believe you understand simply what is the definition of the vapor pressure. Cavitation is simply the formation of the vapor bubbles. So it is the phenomenon of the formation of the vapor bubbles. So vapor is creating here. So all this formation of this vapor bubble, this is it is actually called the cavitation. So it happens when the pressure of the liquid falls below the vapor pressure. I'm repeating again. So when the pressure of the liquid falls below its vapor pressure, then cavitation starts. So I believe you understand the definition of the vapor pressure and cavitation. So during the lecture we'll discuss more and try to correlate it with real life applications.